We're not looking at a real human body here, but it's pretty close to the real thing.
It is pretty close to the real thing, and that's the amazing difference between this, say, and a plastic model. Yes, it's pretty close. This foot is very close to that, the quality of the anatomy in that foot, a real foot in that bottle. Yeah.
And what are the benefits of this, not just for students training in Australia, but around the globe?
Well, not everyone has the luxury of having access to real cadaveric specimens because of all the problems of handling cadavers and storing cadavers and using them over and over again for teaching. So the advantage of this is that someone in any part of the world, say learning podiatry or a foot surgeon, could have this in their office. They don't need any special facility. The students could actually sit in any classroom and look at this. It's a dry powder-based print, but it's got all of the detailed anatomy that a student would need to learn that particular part of anatomy.
So it allows us to see inside the human body
Yeah.
at the moment,
Yeah.
but at this stage with technology levels we can't actually cut in or practice surgery.
No, the multi-property, multi-colour printers have just really been released on the market, and they don't quite have the fidelity and resolution that we require to print what you're kind of suggesting, which is to take something like this hand and recloth it back in skin and fat, and then allow an observer or a student to interact with it by scalpel and cutting into it to find that anatomy for themselves. Because that's the beauty of real dissection, is that you discover the real anatomy for yourself by opening this up. And it's a wonderful thing, it's the best way, but not everybody has that luxury. Not everybody can get access to that material.
Do you think it's going to be one day that we will be able to cut into a real 3D image that isn't a real body, but we can practice surgery?
I absolutely think it will happen. It might seem like something out of a Tom Cruise movie, but I really think it's not that far away, to be honest. And we're hoping that what we're doing is right at that frontier, and then when the technology is able to print what we've segmented and isolated, if we can print that in different quality and textures and feel of materials, then we're almost there. It's not space age, it won't be that long.
And you can pretty much print any part of the body right now?
Yes, we absolutely, yeah. We've got entire cadavers, so we just have to dissect the thing we're interested in and either put it through a CT, put it through an MRI, or do a surface scan. The surface laser scanners are also, if we just want to catch surface detail, then we can use a laser surface scanner as well. But if we want to capture internal anatomy, then we use a CT or MRI. We scan at a very, very high resolution. We then take that data, which is like slices of pages of a 2,000 page book, and each page we look at what is the image on each page, what does it look like, what's the cross section of that image, and what are the structures contained within it. We do that for 2,000 slices, every individual anatomical feature. And then what the computer is able to do, the software, and it's expensive software but it's incredible, is it then can take that data and reconstruct it back into a three-dimensional object. Behind the elbow, where the median nerve is in the cubital fossa, and these are all really clinically important things. The students have to know where this anatomy is at the elbow, because they're going to stick needles in there, and you send it to the printer and it prints.
It's amazing.
And
that's the arm up there.
And that's that particular arm up there, yeah. So you can see the printed version and the computer generated version, and we've got the version in the pot downstairs.